At 37,000 feet, a Boeing 747 can survive the loss of one engine. But on this night, engine number 4 failed, then engine number 2. Seconds later, engines 1 and 3 stopped as well. Every engine on the aircraft was now silent. British Airways Flight 9 had become a massive glider, carrying 263 people through the darkness above Indonesia. There had been no explosion, no violent turbulence, and no storm on the weather radar. Instead, blue-white light was crawling across the cockpit windscreen. Sparks seemed to stream around the aircraft. Smoke was entering the passenger cabin, and the engines appeared to glow from within. The crew had no idea what they had flown into. Below them, the powerless aircraft was descending toward the Indian Ocean. What happened next would change how aviation understood the sky itself. Welcome to History on Pics. On June 24, 1982, Flight 9 was operating a long journey from London to Auckland, with several stops along the way. The aircraft was a Boeing 747-200 named City of Edinburgh. In command was Captain Eric Moody. Until that moment, the journey had been completely routine. The sky ahead appeared clear, the weather radar showed nothing dangerous, and the enormous 4-engine aircraft cruised smoothly over the sea south of the Indonesian island of Java. Then the first strange sign appeared. A faint electrical glow formed around the cockpit windscreen. It resembled St. Elmo's fire, a static discharge sometimes seen around aircraft flying through electrically charged air. But there were no thunderstorms nearby. The glow intensified. Tiny blue flashes began racing across the glass. Outside the cabin windows, passengers could see an eerie light surrounding the wings. The front of each engine appeared illuminated, as though a pale flame were burning deep inside it. Then came the smell. Smoke began spreading through the passenger cabin. It was dry and acrid, more like electrical smoke than an ordinary fire. Then engine number 4 began to surge. Its instrument readings fluctuated violently. The crew followed the shutdown procedure, cutting fuel to the engine and preparing its fire extinguishing system. A Boeing 747 could continue flying safely on 3 engines. For a few seconds, the emergency was serious but manageable. Then engine number 2 failed. Almost immediately, the readings from engines 1 and 3 collapsed as well. In less than 2 minutes, all 4 engines had stopped producing thrust. The constant roar of the Boeing 747 disappeared. Without running engines, the aircraft could no longer maintain normal cabin pressure. The crew transmitted a mayday call. Speedbird 9 had lost all 4 engines, but Flight 9 was still flying. Flight 9 was now trading altitude for distance. From 37,000 feet, the crew calculated that the Boeing 747 could remain airborne for a little more than 20 minutes and glide approximately 90 nautical miles. That sounded like time, but it was not freedom. Jakarta offered the nearest suitable runway. Between Flight 9 and the airport, however, stood the mountains along the southern coast of Java. The aircraft needed to cross the coastline at approximately 11,500 feet. If it reached 12,000 feet without recovering an engine, Captain Moody planned to turn back toward the ocean. There, instead of striking high terrain or a populated area, they would attempt to land the Boeing 747 on the dark sea. While the pilots managed the glide, the flight engineer repeatedly attempted to restart the engine. Again and again, the engines refused to remain running. As Flight 9 descended, the loss of cabin pressure created another emergency. Oxygen masks dropped above the passengers. On the flight deck, the first officer discovered that his oxygen mask had come apart as he attempted to use it. Captain Moody increased the rate of descent so the aircraft could reach denser air, where everyone could breathe more easily. Inside the cabin, flight attendants moved through the aisles, checking masks and helping passengers. Some people held hands. Others stared through the windows at the strangely glowing engine. Several passengers began writing messages to their families. Then Captain Moody spoke over the public address system. "We have a small problem. All 4 engines have stopped. We are doing our damnedest to get them going again." It was a masterpiece of British understatement. The voice was calm. The situation was not. The altitude continued unwinding. 20,000 feet, 17,000, 15,000. Flight 9 was approaching the point where the crew would have to abandon Jakarta and turn toward the sea. Then, near 13,500 feet, engine number 4 responded. And this time, the flame held. After several minutes of silence, 1 engine was producing thrust. It was not enough to restore normal flight, but it reduced the rate of descent and gave the crew more time. Then engine number 3 restarted. With 2 engines operating, Flight 9 could begin a slow climb. Soon, engines 1 and 2 also returned, but the recovery was fragile. As the aircraft climbed, The strange blue glow returned across the windscreen. The crew was entering the same invisible material again. Engine number 2 began surging. Rather than risk losing every engine a second time, the crew shut it down and descended away from the danger. Flight 9 continued toward Jakarta on 3 engines. As Jakarta approached, the runway should have been easy to see. The weather near the airport was clear, but through the cockpit windscreen, the outside world appeared blurred and milky. The glass had been blasted by millions of tiny particles. Its outer surface was scratched so severely that the pilots could see through only a narrow section. The aircraft's landing lights were of little help. Captain Moody and First Officer Greaves would have to land the damaged Boeing mostly by instruments. Outside, the runway lights appeared only as faint points through the ruined glass. The Boeing descended. The distant lights slowly expanded. The runway remained aligned beneath them. Then the main landing gear touched the ground at Jakarta. British Airways Flight 9 had landed safely. All 263 people aboard survived. Only after the aircraft was inspected did the mystery become clear. Flight 9 had flown into volcanic ash from Mount Galunggung, an active volcano on the island of Java. At night, the ash cloud had blended into the darkness. Because it contained very little moisture, the aircraft's weather radar had not displayed it like an ordinary rainstorm. Volcanic ash can produce static electrical discharges around an aircraft, creating blue sparks across the windscreen and glows around the wings and engine inlets. What they could not have known was that pulverized rock from a volcano was producing it. Volcanic ash is nothing like the soft remains of a fireplace. It consists of microscopic fragments of rock, minerals, and volcanic glass. At hundreds of miles per hour, those particles acted like industrial sandpaper. They stripped painted surfaces, scratched the landing lights, and turned the cockpit windscreen nearly opaque. But the most dangerous damage occurred inside the engines. Deep inside, temperatures became high enough to soften or melt the glassy material within the ash. The molten particles adhered to internal engine components. As the deposits accumulated, they disrupted the carefully controlled flow of air needed to sustain combustion. The engines surged, then their flames went out. The same descent that brought Flight 9 dangerously close to the ocean also helped save it. The aircraft continued descending until it escaped the densest section of the ash cloud. As the engines cooled, some of the hardened deposits cracked and broke away. Cleaner air could begin passing through them again. That was why the repeated restart attempts had failed at higher altitude and why the engines eventually returned lower down. The crew had not repaired them. They had kept the aircraft flying long enough to escape the cloud that was choking them. The incident exposed a threat that commercial aviation had badly underestimated. Flight 9 became one of the defining incidents that pushed aviation authorities toward improved volcanic reporting, international ash warning systems, and stronger procedures for avoiding contaminated airspace. The lesson was brutally simple. Pilots should not attempt to fly through volcanic ash. They should escape it. The city of Edinburgh was repaired and eventually returned to service. Captain Moody and his crew were recognized for maintaining control under almost unimaginable pressure. But their survival did not result from one dramatic act. It came from a chain of disciplined decisions. They maintained the aircraft's flying speed. They calculated its remaining glide distance. They established a clear decision altitude. They continued attempting to restart the engines. And when power returned, they did not assume the emergency was over. British Airways Flight 9 landed with every passenger and crew member alive, but its damaged engines and sand-blasted windscreen carried a warning to the entire aviation world. The sky can look completely clear and still contain something powerful enough to silence 4 engines. And Flight 9 was not the only passenger aircraft forced to survive a catastrophe high above the Earth. 6 years later, another airliner would lose a massive section of its roof at 24,000 feet. That story is coming next on History on Pics. Subscribe for more aviation stories like this.